Alright, let's do number 14 together. We're here at the bottom of page 1 in section 2.3, page 1b, that's the video we're in. And your notes in front of you should have the list of steps, but you'll see me kind of talk it through as we do this problem. Number 14, 3 times the quantity, or outside the parentheses, or 3 times in parentheses, 3z plus 5. There's lots of ways to say that. 3 times the quantity, 3z plus 5, minus 7 equals 89. Again, don't panic. If you're having some hesitation, just ask yourself what's causing you to hesitate. In this case, probably those parentheses. We haven't seen a lot of those in our practice, but this is the section where I said they're going to add them. So we were expecting it. And the best news is we've been practicing for this all along. We've been rehearsing, because our very first thing we've been checking for is, are there any parentheses that we need to remove? Is there any simplifying we need to do? And that means parentheses and like terms. So in this case, parentheses, yep, we are going to have to distribute. So I'm going to go ahead and rewrite that entire problem to go ahead and show that distribution. I'm going to multiply the 3 times the 3z and the 3 times the 5. I don't touch the minus 7. There's nothing there to distribute. So it's 3 times 3z plus 3 times 5 minus 7 equals 89. So 3z here, 5 here. Go ahead and do that multiplication. 3 times z is going to be 9z. It's like you're reassociating. The 3 times 3 becomes 9. Plus 3 times 5 is 15. Minus 7 equals 89. So we've done the first step now. We've simplified by removing parentheses. Our second step for simplifying is to combine like terms. So you want to cover up the equal sign. On the left, when you cover up the left, there's only 89 on the right. So there's nothing to simplify, no like terms to combine. But on the left side, we do have a plus 15 and a minus 7. Or if you want to think of that as a plus a negative 7. However you want to think about that. 15 and a minus 7 is going to become a positive 8. So this is actually 9z plus 8 equals 89. So we've taken care of our like terms now. Now where we're at is we're in the ax plus b equals c form, and now we can ask ourselves what is happening to z. So I'm going to go ahead and start that process here and say what's happening to z. And if you were to ignore the other side, if you were to put in a number for z, what's the first thing that would happen? Well, according to order of operations, it would have to be multiplied by 9. After that, you would add 8. So there's 2 steps here. If you want to do that more visually, you can do a timeline. So you'd start with z. The first thing that happens is you'd multiply by 9, and then you would add 8. So it's very left to right list. It's not order of operations. It's just left to right visually. What happens next? What happens next? Now to start undoing this, to solve this, we're going to reverse that list of what's happening and do opposite operations. So you'd go up the list, making the second step your first step and the first step your second or last. So you go up the list and make every operation opposite. Add becomes subtract, multiply becomes divide. If you're like in this timeline deal, go right to left, and instead of plus 8, it's minus 8. Instead of times 9, it's divide by 9. Then what you're going to do is follow that list that you've made for yourself. The first step says to subtract 8. Right to left, as you read backwards along the timeline, the first thing you run into is a minus 8. So that's what you do to both sides. That leaves you with 9z equal to 81. The 8's cancel each other out. 8 minus 8 is 0. That was the whole point. We're trying to move things away from the side that has z involved. Which, as I say side, I realize I hadn't checked for that. Let's just throw that in here. Right here is z on one side. It was, so I kind of forgot to check for it, but it's already on one side, so that's done for us. Okay, back to our undo list here. So we did our subtracting 8, we did that first step. Now according to the list, our second step is divide by 9. According to the going backwards, right to left across the timeline, we run into divide by 9. So that's what we're going to do. Divide both sides by 9. And we get z is equal to 9. 81 divided by 9 is just 9. So now we need to check it, and I'm going to bring it right up here to check. So I'm going to take my original equation, 3 times the quantity, 3 times z plus 5 minus 7, does that equal 89? So I'm going to take my answer of 9 here, plug it in for z, and put a little question mark so I just have a visual reminder for me what it is I'm trying to do here. So nothing to simplify on the right. Let's see what happens on the left. Order of operations makes me look inside the parentheses. I've got multiplication and addition. Multiplication comes first. 3 times 9 is 27 plus the 5. Stay inside those parentheses. 27 plus 5 is going to be 32. On the left, you've got multiplication, 3 times 32. You've got subtraction. Multiplication comes first. 3 times 32 is 96. Minus 7 equals 99. And the whole time, I'm just checking to see if this is a true statement the whole time. And 96 minus 7 is going to be 89. So I do end up with a true statement. You might be able to do this part in your head. Okay, that's totally great. In fact, that's a time saver, so go for it if you can. So it's a true statement. That means my answer checks. I'm ready to show the world what my answer is in set notation. Say, hey, I'm set on this answer. Here it is, all framed up on display, the number 9. That's the answer that works in this equation. Okay, let's jump to a try problem on page 2. Good job.